I will go over this question, which I went over in class, but I'll do it again. It says, this is a 6-mark question. It says A, B, C is a triangle. ADC is a straight line with BD perpendicular to AC. Perpendicular, of course, means at 90 degrees too. AB is 7 centimeters and BC is 12 centimeters. And finally, angle BAD is 65 degrees. And we are required to calculate the length of AC. And this has to be done in 2 steps. We've got to find AD first and then DC and add the answers together. So let's do first of all AD, and we're going to work with this right-angled triangle first. Where the opposite side is there, the adjacent side is here, and the hypotenuse is here. And we want to find AD, which is the adjacent side. So we write SOHCAHTOA down. The adjacent side is required. The hypotenuse is given. So this is in fact a cosine question. So cos theta is adjacent side over hypotenuse. Putting the values in, we get cos of 65 degrees is the adjacent side, which is AD, divided by the hypotenuse, which is 7. And rearranging that the way that we've learnt in class, we get AD is 7 times cos of 65 degrees, which if you put into the calculator will give you 7 cosine 65 equals 2.9, about 2.96 centimeters. Right, and as I taught you, best to store this value in the memory, and I'm going to put it in memory slot A for later use, because we're going to need this value to get the total length later. Now we move to the right-angled triangle on the right, and as I've told you in class, you need an angle and a side apart from the right angle. You need an angle and a side, or you need 2 sides. We only have information for one side. We haven't got an angle or any other side, but if we go to the first triangle, we can now work out the opposite side here and then use this side together with 12 centimeters and Pythagoras theorem to work out the third side. To work out this side, we can use trigonometry again, or we can use Pythagoras with these 2 sides. We're going to use trigonometry. So we want the opposite side. So let's try SOHCAHTOA. And we want the opposite side given the hypotenuse. So this is in fact a sine question. So sine of theta is opposite side over hypotenuse. And putting the values in, we get sine of 65 degrees is the opposite side, which is BD, over the hypotenuse, which is 7. And so BD is 7 sine 65 degrees, which is, get the calculator out, 7 sine 65 is 6.34. Okay. And I'm going to store that in memory slot B of the calculator. Right. With this triangle here, we have the hypotenuse and one of the shorter sides. We just worked that out. So we use Pythagoras. So we're going to call this A, B, and C. And of course, A squared plus B squared equals C squared. A squared, which is DC squared, plus B squared, which is BD, which is 6.34, plus 6.34 squared equals C squared, which is 12 squared. And so DC squared equals 12 squared minus 6.34 squared. Okay, and we can work that out as 12 squared minus B squared. Remember, we stored it in memory slot B. And that gives you 103.75 centimeters. And now we square root it. Square root of 103.75, giving us 10.185. Okay, so now I'm going to put this in memory slot C, by the way. Okay, we've got everything we need. Going back to the triangle, we've worked out AD, which we got earlier. There it is, 2.96. And DC, which we've just obtained, which is 10.185. And so if we add them both together, we get the final answer. And so AC equals AD plus DC, which is 2.96 plus 10.185, giving us, and I put these in memory slots A and C. So I put A plus C, plus C. There we go. 13.144. 13.1 centimeters, and that's the answer to 3 significant figures as given in the question here. Always pay attention to how you should round the answer. Okay, I hope that helps.